Hello everyone and welcome back. My name is Mr. Koval, and in this video I'm going to be going over the properties of water and how it's related to the meniscus and adhesive and cohesive properties. So let's get into this. Okay, so the question for the video is, what would the shape of the meniscus of water be in a polyethylene or plastic tube, and why? So the two choices are concave, which is curving upwards, and convex, curving downwards. So what is the answer to this question? The answer to this question is based on the intermolecular forces that are occurring between water molecules and the surface of the tube that we are interested in. We're told that in this particular example, the tube is made out of polyethylene, which is plastic, and they give us the the formula for that. And you can see it's just hydrogen carbon atoms bonded together. So this is a nonpolar molecule. So all of the carbon hydrogen bonds are nonpolar. The difference in the electronegativity between hydrogen and carbon is less than zero point 0.5. I think it's like 0.4, right? So that's a pretty nonpolar bond, and that's all you have in this molecule. And so therefore the molecule is nonpolar. So, what is the predominant force in any nonpolar molecule? That is going to be the London dispersion forces. Okay, so you have London dispersion forces that are involved in the plastic of the tube. But what about water? Water is H2O, and so you can see here, water being H2O also has London dispersion forces, but it's also a polar molecule, so it also has dipole-dipole interactions. But it has hydrogen that is bonded to oxygen, so it can also exhibit hydrogen bonding, which is the predominant force in water, right? So here you have the predominant force being the hydrogen bonding between the water molecules, uh, but then for the plastic, that's going to be your London dispersion forces, and so they have different forces, and so therefore, when you have water in a plastic tube, this could be a capillary tube, for example. You'll see that this is going to be concave upwards, curving up or curving down, if you want to think of it this way. So it's curving down at the edges here. And the reason for that is because the water molecules are more attracted to each other than they are to the plastic tubing, right? And that has to do with the fact that the type of bonding that we have here, hydrogen bonding, is much stronger than the bonding or the attractive forces in the plastic. So you had the van der Waals or the London dispersion forces due to the nonpolar molecule. Um, but you have the hydrogen bonding here. So if you remember, like dissolves or like is attracted to like, or things like that. You'll see that, okay, so the water molecules, because the hydrogen bonding is so much stronger than the London dispersion forces, they're going to be more attracted to each other. That's your cohesive forces. So the cohesive forces are the forces where the molecules, the same molecules of the substance, attract each other. And then you have the adhesive forces where the molecules are attracted to some other surface, not to each other, right? So there's a competition here, balancing between the cohesive forces of the molecules attracting each other versus how strongly they're attracted to the surfaces other than each other. So other surfaces or other substances, right? So here, because the water molecules exhibit hydrogen bonding, that's a much stronger force. So they're going to be more strongly attracted to each other rather than to the plastic in the tubing. And so you could see that the attraction is going to bring this in closer, right, going this way rather than this way. They're not going to be much attracted to the tubing. So you get this concave shape of the meniscus. But if you go over here to the glass, glass is made up of silicon dioxide, among other things. This is going to have charged particles in it. So there's going to be some attraction here, some charge. And so because this is a polar molecule, water has a dipole in it. It has a plus charge and a minus charge. It has a positive and negative poles in the molecule. So the charged part of the molecule is going to be attracted to the glass, the charge in the glass. And so you'll see here that the attraction to the charged particles in the glass are going to be kind of more stronger than that bonded together. So for the hydrogen bonding, right? So, but the hydrogen bonding is still there. So what happens is the water molecules are attracted to the sides of the glass tubing. So they're going to move upwards and they're going to kind of go up into the sides of the tubing here. And because of the hydrogen bonding, you've got this kind of meshwork or network of attraction forces between the molecules. So if the molecules are attracted, if one or several molecules of water are attracted to the sides of the glass tubing, then they're going to kind of go up because they're attracted, but then they're going to pull the rest of the molecules with it, and you get this bending upwards, trying to climb the side of the glass, and that gives that more convex shape like so. And so that's why you get different types of meniscus depending on what the material of the tubing is that the water is in. And again, it depends on what substance you have as well. If this was mercury, right, if you had mercury in your glass tubing, the mercury is not going to be attracted to the glass, and so you get a convex meniscus for mercury because that's a different substance compared to water. So you have, again, it's going to be a balance of the adhesive forces where the molecules or the particles are attracted to the surface of the tubing versus the cohesive forces where the particles are attracted to each other and what that balance is. So depending on what substance you have in the tubing, depending on what material the tubing is, it's all about a balance of a balance of the intermolecular forces that are at play between the molecules themselves and the tubing, and so which one is going to be stronger than the other. And so that is an upshot or summary of why you see different meniscuses or menisci, however you say the plural, when you're dealing with certain substances. And for water, we would expect, again, for plastic, water would have a convex meniscus. In plastic, it would have a concave meniscus. In glass, based on the competition of the intermolecular forces, the adhesive forces, and the cohesive forces. And so that's it for this video. I hope you enjoyed the video. If this helped you learn or understand why water is convex or concave in given material, then please like the video, share the video, hit that like button somewhere over here. Also, do me a favor, subscribe to my channel. Do it now. Also, hit that notification bell. When you do that, click all so you can be notified by all the videos I put out. Finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me and have a great day.